Hello and welcome to the interactive booster on how to use the periodic table effectively. Throughout this booster, I'm going to ask a question. Whenever I do, just pause the video, have a go at doing the answer yourself, and then when you're ready, press play again and I'll go through the answer. So we're going to go through 4 little tricks we can use the periodic table for, each of which is really useful for a whole range of different things. So the first thing we'll go through is how to use the periodic table to really quickly find the electronic configuration of an element. So let me just show you how quickly you can do this. So I'm just going to pick an element, I don't know, phosphorus. I can tell you like that, if I can click, the last electron in phosphorus is in 3p3. That's its outermost electron. Magnesium is in 3s2. So how did I do that so quickly? I use this little trick here. So if you want to know where the outermost electron of an element is, the shell will be equal to the period number. So if you've got a periodic table yourself at home, grab it out. Let's look at magnesium and go back to that. So magnesium's period is period 1, 2, 3, because periods go across. So magnesium's outermost electron is in shell 3. The subshell where the outermost electron is the block. Now, just to go through the blocks, and I would annotate your periodic table if you haven't already, groups 1 and 2 are the S block. This divot in the middle is the D block for dinosaur. This here is the P block. And these two at the bottom here, which we don't really do too much A level, but that's the F block. Okay. So magnesium is in the S block. So its outermost electron is in 3s. To find the number of electrons that are in that subshell, you count how many columns across the element is in that block. So in the S block, magnesium is 2 columns across, so its final electron is 3s2. And then all you need to do is fill up to there. So we have 1s2, 2s2, 2p6, 3s2. Yeah, so it's dead easy, dead quick, and that can tell you loads of stuff about the element. So I know it's got 2 electrons in its outer shell, 3s2. So I know it's going to have a 2+ charge. There's lots of other stuff you can get like that. So this is what I would get on a flashcard with maybe a couple of examples. So stop the video, make that into a flashcard with a few examples. Welcome back. Let's try and apply it then. So I'm going to put down 4 elements. If you can tell me where is their outermost electron. So we'll have nitrogen, sulfur, lithium, and fluorine. Pause the video. Welcome back. So nitrogen is in the second period down. It's in the P block, and in the P block, it's in the first, second, third column across. So nitrogen's outermost electron will then be in 2p3. And then you just fill up to there. Sulfur, again, is in the first, second, third period down. So that'll be shell 3. It's in the P block. And it's the first, second, third, fourth one across. So 3p4. Lithium will be 2s1. And fluorine will be 2p, 1, 2, 3, 4, 5. So really quickly, we know how many electrons are in their outermost subshell and what shell that'll be in. Okay, I'm just going to give you 2 more to have a go at. Before I do, I just want to point something out. Next to period here, for the shell number, I've put a little asterisk. And that's because on the D block, Now the D block, remember, is this little divot in the middle. For whatever reason, the D block is moved down 1. So although scandium, titanium, vanadium, etc. are in period 1, 2, 3, 4, scandium, titanium, vanadium, etc's outermost electron is in shell 3, because the D block has been shifted down 1. So bearing that in mind, have a go at these two. Let's do chromium and, just because it's a weird sounding one, yttrium. Have a crack at this. You pause the video. Okay, welcome back. So chromium is in period 1, 2, 3, 4. But remember, the D block has been moved down 1, so it's actually in shell 3. It's in the D block, and we've got 1, 2, 3, 4 electrons in there. Okay, so you'd imagine that's 3d4. However, we'll come back to that one in a second. Yttrium, 1, 2, 3, 4, 5, it's been moved down 1, so 4, D, and then yttrium in the D block is the first row, so 1. However, chromium, I'll circle them, and copper, you've really got to watch out for them because they're a little bit weird. If I do the 4s and 3d for chromium, you'd imagine chromium would be 4s2, 3d4. Like so. However, chromium can be more stable if it's able to have the same number of electrons in each of these orbitals. So as a weird exception, and you've just got to remember it, chromium shunts one of its 4s into its 3d. So as an exception to the rule, chromium is actually 4s1, 3d5. And it does that so that it can have the same number of electrons in each of those d orbitals. So chromium's a weird one to watch out for. Very similar with copper. You'd imagine copper would be 4s2, 3d9, using the rules I just showed you. But again, that would give it 2, 2, 2, 2, 1, so it shunts one of its 4s into its 3d, so it's 4s1, 3d10. To sum up, as an exception to the rule, chromium and copper will have one more in their 3d, because they've shunted one out of the 4s. So they have a 4s1 configuration. Okay, so chromium and copper, weird exceptions to the rule. So that's our first trick then. So we can tell, with the exception of chromium and copper, we can tell where that outermost electron will be. Okay, let's look at our second rule, our second trick I should say. This is a much, much easier one. This is just lined up, finding the number of bonds an element will usually make. I say usually because there's always exceptions to the rule. And it works like this. Your noble gases almost always make 0 bonds. Your halogens will usually make 1. Oxygen and sulfur, etc. will make 2. Nitrogen and phosphorus will make 3. Carbon and silicon will make 4, and then it goes back down to 3, 2, 1. Ignoring the D block. We're not going to talk about the D block, don't worry about that. So ignoring the D block, usually it's 0, 1, 2, 3, 4, 3, 2, 1. So it starts at 0, it goes up, then when it hits carbon, it goes back down. So I'm just going to say a few, and really, really quick, I want you to tell me how many bonds that element will usually make. But the idea is to be able to do this quickly so it doesn't tie your thinking up in an exam. Okay, so how about bromine? It'll make 1 bond. How about strontium? it'll make 2 bonds. And again, if you need more time, just pause the video after I've asked the question. How about boron? It'll make 3 bonds. 0, 1, 2, 3, 4, 3. How about germanium? 4 bonds. 0, 1, 2, 3, 4. How about oxygen? 0, 1, 2. How about phosphorus? 0, 1, 2, 3. Yeah. So really quickly, and then that'll help you when you're doing dot and cross diagrams, because you'll know how many pairs of electrons it's going to share. Okay. And it'll help you in lots of other things as well. When you're thinking about shapes, you'll know how many bonds it usually will make. So that'll tell you usually what shape it is. Now, in order to find the shape, we don't just need to know how many bonds it makes, we would also need to know how many lone pairs they have. So again, this is usually, there are exceptions to the rule. The ones which tend to be the exceptions are like this little divot here. So these can sometimes make more bonds than what they're supposed to, what they usually do. But usually, the number of electrons, again, it's just a little trick. So the number of lone pairs of electrons the elements have is 4, 3, 2, 1, 0. So your noble gases have 4 lone pairs. Usually these will have 3, these will have 2, these will have 1, these will have 0, usually. Okay, so again, you could annotate your periodic table. You can just have lone pairs, 4, 3, 2, 1, 0, usually. Again, there is exceptions to the rule. So, let's do it again then. I'll ask a question, just pause the video after my question, come up with your answer, then press play again. Again, it's all about being quick. We don't want to get tied up in an exam having to spend 5 minutes figuring this out. Just look at the periodic table, use this trick to calculate the lone pairs. So how many lone pairs does sulfur usually have? 2, right? 4, 3, 2. How many lone pairs does silicon usually have? 0. 4, 3, 2, 1, 0. How many lone pairs does bromine usually have? 3. 4, 3. We'll do one more. How many lone pairs does oxygen usually have? 2. 4, 3, 2. Right, so it's dead quick. It's really helpful. That'll help you with shapes, loads of other stuff as well if you can do that really quickly. And our final trick is actually basically the same as finding the number of bonds. It's to find the charge that an element usually gets. And this is assuming it's not making any bonds to anything. So the charge, again, is start from your noble gases. They usually don't have a charge because they're already happy. They've got 8 electrons in their outer shell. Your halogens, well, let's go back to that trick earlier and let's really quickly find the electronic configuration of, let's say, fluorine. Where's its final electron? Pause the video. So fluorine's final electron will be in 2p, 1, 2, 3, 4, 2p5. So if I fill that up, we'll have 1s2, 2s2, 2p5. So your fluorine in every other halogen is going to have 7 electrons in its outer shell. Obviously chlorines will be in 3s and 3p, bromines will be in 4s and 4p, but they've all got 7 in their outer shell because they're 1, 2, 3, 4, 5, 6, 7 across on the periodic table. So by counting across, you can see the total number of electrons in the outer shell. Again, not including the d block. So if they've got 7 electrons and they need 8 to be stable, well, they're going to need to get 1 extra electron. So your halogens usually have a -1 charge. Oxygen has 1, 2, 3, 4, 5, 6 electrons in its outer shell. It needs 8, so it needs 2 more, -2. Nitrogen, it needs -3, and so on. So again, you can use the periodic table to quickly figure out what charge your elements will have. And I should say as well, these negative charges only apply to the non-metals. Obviously the metals will have a positive charge, won't they? Okay, so we've got 4 tricks there we did in total. We figured out how to calculate really quickly the electronic configuration of your elements. We figured out how to find how many bonds they would make, and that's actually the same trick as finding the charge. It's just counting across from your noble gases. And then we also did a little trick to find really quickly the number of lone pairs that they have. So 4 things that are going to be really helpful in loads of different topics if you can quickly get that from the periodic table. And actually a summer pack that we're going to set over summer is using the periodic table effectively. So if you've now bossed this because of doing this booster class, you'll absolutely smash through that summer pack. Okay. Thank you very much, guys. Have a nice day.